So, when you hear the words nuclear reactor, most people imagine something like this: huge power plants, massive cooling towers, billions of dollars in construction, and decades of planning. But what if I told you that this is also a nuclear reactor?
It's called a microreactor, about the size of a truck or a container, but powerful enough to supply energy for a small city, a remote community, a military base, or even the energy hungry AI data centers of the future. In this video, we'll break down what microreactors are, why they are attracting attention right now, the promises they hold, and the challenges they face, and whether they are really the future of energy or just another shiny pitch.
So, let's start with the basics. Traditional nuclear reactors are massive. They generate electricity at the gigawatt scale, enough to power millions of homes. But they're also extremely expensive, slow to build, and politically difficult to approve. Microreactors, on the other hand, flip that model. Instead of gigawatts of power, they produce anywhere between 1 to 20 megawatts. That's small compared to a full scale plant, but enough to keep tens thousands of homes or an industrial facility running. The key difference is modularity and portability. They are compact, factory built, and designed to be shipped, installed, and even removed when needed. Think of them as a plug and play nuclear power. Alright, why is this idea gaining sudden traction? The answer is energy demand. Global electricity use is skyrocketing. AI data centers, electric vehicles, crypto mining, just the fact that more of our lives are doing digital. All of this is pushing the grids to their limits. At the same time, we need cleaner energy sources. Solar and wind are growing fast, but they are intermittent. Batteries help, but large scale storage is still very expensive. Here's what makes microreactors so appealing, at least on paper. They're scalable. Need more power? Add more units. They're faster to deploy. Instead of waiting for 10 to 15 years for a giant reactor to be built, a microreactor could be assembled and switched on in just a couple of years. And because they are smaller, the risk of catastrophic accidents is reduced. In theory, the safety systems are simpler and more reliable. Supporters even argue that microreactors could help decentralize the grid, reducing reliance on massive infrastructure and bringing clean energy closer to where it's needed. But before we get carried away, let's talk about problems. The first, the most obvious one, is public trust. Nuclear power still carries heavy stigma, and convincing people that small reactors are safe is not going to be easy. Second, waste. Even small reactors produce radioactive material that has to be stored for thousands of years. That problem doesn't just magically disappear. Third, while smaller than traditional plants, microreactors are still extremely expensive compared to renewables like solar or wind. And finally, regulation. Getting approval for nuclear projects is notoriously slow, and unless government streamlines the process, these reactors could get stuck in a legal limbo. So, where does that leave us? Microreactors are not the silver bullet. They won't be replacing renewables anytime soon, and they won't solve all our energy problems overnight. But they could fill important gaps, supplying power where renewable is falling short and backing up critical infrastructure that are helping industries or regions that can't rely on traditional grids. Most experts agree that if they succeed, then it'll start niche markets like military bases, Arctic towns, isolated islands, and maybe down the line, high demand data centers. From there, if costs are falling and the trust grows, it could scale. Microreactors represent one of the boldest ideas in energy right now. Shrinking nuclear power from giant plants down to something you can haul on a truck. But will they actually deliver or end up getting stuck in prototypes? Only time will tell. Thanks for watching this video. I have linked all my sources down in the description below. Feel free to comment and ask me any questions about SMRs, and I'll see you in the next one. And don't forget to like, share, and subscribe.